In this tutorial, we'll be solving system of linear equations using Excel. Now let's take one example of system of linear equations. In this example, we have three equations with three variables x, y and z. Now we can solve this solution using matrix technique. What we do is we represent the coefficients of x, y and z in terms of a matrix. Let's say that matrix is matrix A with all those coefficients. Another matrix X, which consists of all the variables x, y and z, and on the right hand side the matrix B, which contains the right hand side of the equations. Now when A into x is B, so x can be calculated as A inverse B. This is the simple technique which we'll be solving in the Excel. Now this technique can also be used in MATLAB to solve for such equations. In MATLAB, what we do is we represent matrix A as 6, 12, 4, semicolon 7, minus 2, 3, semicolon 2, 8, 9, and then matrix B is written. The solution can be calculated in MATLAB. In the command window, we write inverse I and V, inverse of A star B, and then we click enter. We get the solution as 3, 5 and minus 2. The other ways to represent it in the MATLAB is we can write A inverse A raised to power minus 1 star B, or A left division B. The solution again comes out to be the same, that is 3, 5 and minus 2. Now let's try to solve this using Excel. In Excel, what we do is first let's paste this equation over here. Okay, now we have the equations over here. Now this equation, in Excel, these equations can be solved by two different ways. One is using solver technique, the other can be solved using matrix technique, which we just learned in the slides. Now first I'll teach you how to solve this using solver technique, that is present in this data tab, that is solver technique. For this, let's arbitrarily assume any values of x, y and z. Let's say x is equal to 1, y is equal to, let's say, 0, and z is equal to, let's say, minus 2. Arbitrarily any values. Now we'll put these assumed values in this equation and get their values. Let's say equation 1 is equal to, let's say this is 6 star x plus 12 star y plus 4 star z. This is the value of equation 1 when we'll put these assumed values of x, y and z in that equation. Similarly, we'll do it for the other two equations also. 7 star x minus 2 star y plus 3 star z. We'll check it, 7x minus 2y plus 3z. Okay, done. And then the third equation 3 is equal to 2 star x plus 8 star y and star z. Now we have these values of equation 1, 2 and 3. When we put these arbitrary values of x, y and z, we can, before we move further, let's again recheck these values. 6x plus 12y plus 4z, okay, it's correct. 7x minus 2y plus 3z, correct. 2x plus 8y minus 9, okay, these are correct. Now what we do is we go to this solver over here. Now over here it says set an objective. Now we have the objective that sum of all these values of x, y and z, when we put, they should come out to be 70. In equation 2 it should be 5, in equation 3 it should be 64. Now we can pick up any equation. Let's assume I picked up equation 1, that is over here. This is equation 1 to a value of, it says a value. I have defined that sum of all these values of x, y and z when we put in equation 1, should be 70. It should 70. And changing the variables, okay, we will change the variables for x, y and z. X, y and z are to be modified or to be calculated in such a way that equation 1 should come out to be the value of 70. Now what about the other two, equation 2 and equation 3? Now equation 2 and equation 3 will be defined in subject to constraints. Okay, before that let me delete the previous constraints. Okay, subject to constraints. Now subject to constraints are equation 2, sum of all the values of x, y and z when we put in the equation 2 should be 5, and similarly in the third it should be 64. So for that, let's define those constraints. Cell reference that is equation 2. Now we'll not be making equation 1 because we have targeted equation 1 already, that it should be 70. Now it should be, constraint should be equation 2 also and equation 3 also. So equation 2 should be equal to 5 and equation 3 should be equal to 64. So we have these constraints, that is equation 1 should be 70, equation 2 should be 5, and equation 3 should be 64 by changing x, y and z. Okay, and then we'll click solve. That says the solution is found. So the solutions are 3, 5 and -2, and those sums are 75 and 64. So this is how we solve for using solver technique, and we already know that x is 3, 5, y is 5 and z is -2. Now this was one way to solve this set of linear equations using Excel solver technique. Let's solve by another method, that is by matrix. For that, let me highlight it that this which we did was of technique 1. Now in technique 2 we'll define one matrix, that is, let's say define that matrix as 6, 12, 4, 7, -2 and 3, 2, 8 and -9. This is one matrix consisting of all the coefficients of x, y and z which are there in the equations, and over here we defined the values of these equations 75 and 64. Now we'll calculate the inverse of this matrix A. This is our matrix A and this was our matrix B. For that, what we do is, now this matrix A is of size 3 by 3. So what we do is we first highlighted 3 by 3 size like this, and we'll write equal to. And for in Excel, for matrix multiplication, all the formulas or all the terms which we use in Excel, they'll start with M. Let's say M inverse. It says M inverse. M inverse. Now it says we need to pick up an array. Now array is this array, 3 by 3 array, and then we write close the bracket, and when we press enter, it will give us only one value. That means somewhere we have done a mistake. Okay. For that, what we do is we again pick up a 3 by 3 matrix. M inverse highlights the array. Now for when we highlighted the array, we'll get our solution by pressing Ctrl Shift and enter. By pressing Ctrl Shift and enter simultaneously. So this is what we have, the inverse of matrix A, which is of size 3 by 3. And now let's write the values of x over here, the value of y over here, and the value of z over here. To get the values of x, y and z, what we do is we again highlight an array of size 1 by 3, 3 by 1, right. Now we'll multiply this inverse of A with the matrix B. For that, matrix multiply It says return the matrix product of two arrays. So first we'll pick up two arrays. So the first array should be the array of A inverse, comma, and then should be the matrix B. Again, for array, the solution will be Control Shift and Enter. So this is what we have. For X is 3, Y is 5, and Z is 2, which we already did by solving Excel solver technique, and we already did by using MATLAB technique. So there are many ways to solve the system of linear equations. Now let's take another problem consisting of more than 3 variables. Let's take another technique. Over here I picked up this problem from the net. This is a problem of 4 by 4. Okay, is not there, so what we do is we'll minimize our tree. We'll try to import it over here. So against the same, we'll write x to be any arbitrary value 1, y to be any arbitrary value 2, z to be any arbitrary value -1, and w again to be 4, any values of x, y, and z. Now we write equation 1, which is we put the values of x, y, z in w in this equation using these arbitrary values. So it should be 3 star x minus y plus 2 star z minus 4 star w. And similarly we'll do it for other 3 equations also. X Now done for all the equations. Let's recheck before we proceed further. 3x minus y plus 2 xy. Okay, go here. X plus y minus plus 3 plus 2w. Okay. Minus x plus 2y minus z minus 3w. 4x minus 3y plus 6. Okay, we're done. Again, we'll go to the solver. Okay, set the objective. I will set the objectives for objective of this. Let's say now let's take some other objective. Equation 2. Let's set to be a value of, okay, we need a value of equation to be 28 by changing x, y, and z. Okay, subject to conditions for equation 1, 3, and 4. So add. Equation 1 to be equal to 27, equation 3 to be equal to -29, and equation 4 -15. So we have all the equations. I'll take this so that if any value of x, y, and z is negative, it will show, otherwise it will convert that negative to 0. So x is -2, y is -1, z is 5, and w is 8. These are the solutions. So let's now try to solve using Excel technique using matrix technique. Matrix technique, what we do is, let's do it over here. Area of, it's an area of go back to done to reverse, pick up the array and then control shift enter. X, Y and Z, array 1 comma array 2, and then so we can cross check our values of x, y and z. -2, -1, 5 and 8. So this is how we can solve set of linear equations, either more than any two variables. We can solve using Excel by two different ways. One is by solver technique, the other can be by using matrix multiplication. If you have any query related to this, my email ID is there, is in the description. You can ask anything. Thank you very much.